Hello everyone, welcome to my presentation for FairVision. In this project, I am building an AI system that can look a person face and predict their age group out of 9 possible options. A common problem is AI face recognition is that models can have bias. This means they might perform very well for one group of people but make a lot of mistakes for another group based on their race or gender. In this video, I will show you how to build this system using PyTorch, how I fix early performance issue by changing the model design, how I measured fairness, and finally how the finished model works live on a web application. Let's start with how the data is loaded. We use the FairFace dataset for the Hugging Face hub. To feed this image into our training loops, I wrote a custom piece of code called FairFace Torch dataset. As you can see right here is the code. Our programs loaded a face. It doesn't just look that the image and the age label. It's also extract the race and the gender of that person at the exact same time. We keep this demographic information hidden from the models during trainings, but we use it later to check if our models is begin fair to well subgroups. To help the models learn better, we use two different image settings. For training, we use data arguments. It means we randomly filter, rotate, and simply change the colors of the pictures so models learn to recognize face under the different lights and angles. For validations, we keep the picture completely clean and normal. Next, let's talk about the brain of the system model architecture. At first, I built a simple custom 5 layers convolutional neural network from string. It was small and fast. It wasn't smart enough to learn the thing. Subtle difference on humans' face that show age like mirror weakness or skin texture. Because of its accuracy stuck around 50.92%. To fix this, I upgrade the system to a famous deeper network called ResNet 50. This network comes pre-trained 1 million of images, meaning it's already know how to recognize shapes, lines, and design. In my code on the screen, you can see I removed the standard output layers and built a custom head. I added dropout layer set 0.6 prevent the model from memorizing the date too closely, followed by a finally liner layer that maps the features strictly our 9 age groups. To train the network, we use AdamW optimizer and cross-entropy loss functions, which tells the models how far off the guesses are so it can control itself. But what makes this project special is how we measure success. We don't just call one overall accuracy source. Instead, my evaluation code separates the test result by race and gender to see exactly where the model strayed. I also wrote a custom tool called an error security index. This code checks how bad a mistake is. For example, if a person is 25 years old and the model's guess then are 35 that its mirror errors just one age break. But if the model guess are 70 that is Cross-Entropy error. Thank you to these deadlines tracking and our ResNet 50 upgrade, our training accuracy climbed past 70% and our validation accuracy jumped 58.64%, while making the model much fairer across different demographic groups. Finally, let's look at the finished product in actions. We saved our best model weights and connection them its live web application. When a user uploads new fair images to the front end, our apps take the picture and automatically process it using exact same size and setting used during our training please. The image sensor is the parser strangely our training ResNet 50 model. In real time, the backend cultivate the probability and displayed the final predicted age group direct on screen. As you can see right here by bring our code out of the notebook and into an easy to use web dashboard. We can quickly test new image and make sure our AI system accurate, transport and ready to real world use. That concludes my technical overviews FairVision. Thank you very much for listening.